Okay, the last category we have is inverse trig functions. So first, I expect for you guys to be able to evaluate expressions without using a calculator. So most likely there's going to be a calculator portion of our test and a non-calculator portion, just like normal. So these would be on the non-calculator portion. So it says inverse cosine of 1/2. So I always think of a unit circle in these. So I will draw the unit circle. And you're finding when the x value of the unit circle equals 1/2. Cosine is x values. That means you go over a little bit, up a lot. That's when you have 1/2 common square root of 3/2. So that's not the one that was right here, which was the opposite, square root of 3/2 comma 1/2. That was pi over 6. This one is the pi over 3. Now remember, cosine is inverse cosine. Everything has to be 1 to 1. So it's restricted. It's on the restricted domain. So that would be from 0 around to pi. So pi over 3 is in that domain. So it's equal to pi over 3. Okay, I always like to think, where do I have every single x value and none of them repeat on my unit circle? So that would be why it's 0 to pi. Arc sine, so that's the same as inverse sine. So arc sine of 0, so on my unit circle, 0, it's saying where is my y value equal to 0? So my y value is 0 right there, at 0. Arc sine is restricted from negative pi to pi. 0 is on that, so 0 is the answer. So this one's a little bit trickier. It says I want to find the sine of arc cosine of square root of 3/2. Okay, square root of 3/2. So when is your cosine value equal to square root of 3/2? So that would mean that your x value goes out a lot, it goes up a little bit. So that's here. That was like pi over 6. If pi over 6 is in 0 to pi, so that's that value. So now I'm computing sine of pi over 6. Well, sine of pi over 6 is the y value at that point. So since this was over a lot, square root of 3/2, up a little, so 1/2, the answer is 1/2. All right, and then this is kind of going the other way. So it said, what if your cosine value is pi over 6? So cosine of pi over 6, that's the square root of 3/2. So it's saying inverse sine of square root of 3/2. Saying when on your unit circle is your sine value equal to square root of 3/2. Okay, that's up here. That's because it equal over a little 1/2 up square root of 3/2. So that is that pi over 3. Now always check to see if it's in the domain that you want. The sign is restricted to negative pi over 2 to pi over 2. And pi over 3 is the value that's in that range. That's it. Okay, next up, find the derivative of each function. Okay, so I told you that you're going to need to know 2 different things for your test. So the first one is right around here, the derivative of inverse sine. Is 1 over the square root of 1 minus x squared. Now, if you want to do inverse cosine, all of it is with a negative out front. It's definitely there's definitely a pattern to these. So if you memorize 2, you definitely have 4 memorized. So you might as well just try to memorize all of them. Ones that pop up on the AP test most of the time are these 2. So the derivative of inverse tangent is 1 over 1 plus x squared. So these are the ones that you'll see most often. So if I'm finding y prime, this is going to be a chain rule. The 2 goes to the front. I have inverse sine of x inside still, and now it goes to the first power. So you're going to need that, and then write it, times the derivative of what was inside, so the derivative of sine. So it's 1 over the square root of 1 minus x squared. All I do is maybe tidy it up a little bit. So I probably combine it and write it like that. All right, this one, it looks similar, but it's actually very, very different. So, inverse sine of something, this is like a u. If I was doing inverse sine of u, it would just be 1 over the square root of 1 minus u squared. So x squared is going to be x squared. And then you always need to do the derivative of u at the end. So my derivative of x squared is 2x. So it's 2x all over the square root of 1 minus x to the 4th. And that's how you need it. So there are your two answers. All right, next up. So it says if f of x equals x times inverse tangent of x, find f prime of 1. All right, so this is using the other formula. So f prime of x, I'm going to do the product rule. So first times derivative of the second. That was what I told you needed to know. Plus first times the second normal. So f prime of 1 is like 1 then. So it's f prime of 1 equals 1 times 1 over 1 plus 1 squared, so 1, plus 1 times inverse tangent of 1. Oops, I put 1 there. It should be x above. Alright, so inverse tangent of 1. So that means when I take the tangent of something, I want to get 1 out. So, let me try to theta, so I'm not confused with our x that we already got. So that means sine over cosine has to be 1. That's what tangent is. So basically we're saying when are sine and cosine equal to each other? So they're equal outside of 1. So inverse tangent of 1 is pi over 4. Let me write that out first. I get 1 times 1 half plus pi over 4. So 1 half plus pi over 4 is your answer. Now, if you found the decimal version, should get 1.285. But again, this could be on your non-calculator part, so I would know how to find inverse tangent of 1. Next step, we're going to integrate. So I can see that this is in the form for inverse tangent. You can pull the 6 out to the front if you'd like to see it that way. You don't have to though. Same thing. So it's just 6 inverse tangent of 1 square root of 3. Okay. Okay, this is where it gets a little interesting because you need to know what these inverse tangent values are. So 6 is going to be on the outside. So inverse tangent of root 3 minus inverse tangent of 1. Well, we just found inverse tangent of 1. We said that was pi over 4. We're good there. But what about the inverse tangent of square root of 3? So we're trying to find when tangent of theta equals square root of 3. So in other words, sine over cosine equals root 3. Well, the things that deal with root 3 are the points 1 half comma root 3 over 2 or root 3 over 2 comma 1 half. So think about it. Which one has to be sine? Which one has to be cosine? I would need root 3 over 2 divided by 1 half in order to get root 3. So you can think of it as root 3 over 2 divided by, like the old sign, 1 half, which is root 3 over 2 times 2 over 1. That's how I knew. Okay, you can also think of it as the 2 should cancel it. Okay, so we need for sine to be root 3 over 2. Okay, that's this point. So where does that point happen on our unit circle? It means you go over a little, up a lot. That's at pi over 3. Okay, so you can simplify. You can get common denominators if you want. So it's 6 times, let's make them 12. So 4 pi over 12 minus 3 pi over 12. So it's 1 pi over 12. So 6 times pi over 12. So it's pi over 2. And your answer should be pi over 2. Okay, this one's a little bit different. Let's see, what should we do here? Okay, this right here is e to the x It's not. I think I made a typo. I think I meant for this to be e to the 2x. Yeah, I'm very nice making this. Plus 1. Okay, so I'll correct that on yours before I send it out. Okay, so e to the 2x. What that is e to the x squared. See how you would multiply in, you get e to the 2x. Okay, so that's our u. So we're going to let u equal e to the x. So then du is going to be e to the x dx. So when I replace, I have 1 over u squared plus 1 with a du. So that's inverse tangent of u plus c, which is inverse tangent of u to the x plus c. So that's our solution. Don't forget your plus c, it wasn't a definite interval, there were no numbers. And let's see where I am on time real quick. I only post 15-minute videos on YouTube too. Alright, 4 more minutes. I think I can do it. Alright, so this last one, this is set up, it looks like it's going to be inverse tangent, but it has a 16 out front. So think about to yourself, what is being squared there? That is 4x being squared. So that's our u. We need to let u equal 4x. So du is going to be 4 dx. So it's 1/4 du equals dx. Now I'm ready to replace. So I have u is 0, so u of square root of 3 over 4. For the 1/4 out front, it's 1 plus u squared with the du. Okay, u of 0, if I plug in to this equation here, u of 0 is 0. U of square root of 3 over 4 is 4 times square root of 3 over 4 is square root of 3. This is square root of 3. This is 0. Alright. Right, so this is going to be 1/4 inverse tangent of u going from 0 to square root of 3. So it's 1/4 inverse tangent of square root of 3 minus inverse tangent of 0. Okay, we just found inverse tangent of square root of 3. Okay, it was pi over 3. Inverse tangent of 0, that's when sine is equal to 0 and cosine is equal to 1. That's right there. So that's at 0. So it's pi over 12. And the last one, we're going to let, this is e to the 2x squared. So we're going to let u equal e to the 2x. So du is e to the 2x times 2 du. So it's 1/2 du equals e to the 2x du. Or e to the 2x dx. Alright, so it's 1/2 out front. This bottom is 1 minus u squared du. Okay, so that was our inverse sine. So it's 1/2 inverse sine of u. U is e to the 2x plus 2. And that is it. Let's see how to do this stuff.